guys. I'm so excited because we are still going to learn, even though I am not here, because the wonderful world of YouTube. I know, you're excited, I'm excited, I'm still here, you hear my voice, you see my little picture in the corner. I know, it's like I'm still here, right? Okay, so here's the thing with this video. Before I move on to the next slide, I'm going to ask that Annalena just pause the video so that way whoever's still writing can finish writing and then we can move on. All right? Make sure that you let her know when you're done. Okay? If you missed something, you didn't understand what I said, you can ask that it be rewinded, or you can watch it later on your own, right? Also, please don't act like fools. Like, you're so smart. You're too good to be acting all crazy. Like, don't be silly. All right? No funny business. Now, sick? I know I'm not there, and you're gonna so badly want to get up, but just don't. All right? All right. Let's go. So we're going to be going back over radicals and surds, but in a different way, okay? Our objective today is to simplify radicals. Now, Annalena, if anyone is still writing, will you please pause? Now, remember this, okay? We have exponents, and we know the properties of exponents. So, whenever I have two numbers, A and B, that are being multiplied by each other, and I raise that process to an exponent, n, all I have to do is to distribute that, right? And I get a to the n times b to the n. But please remember, this only works on multiplication. Do not, and I repeat, do not do this. This is not true. If I see you doing this, I'm going to come find you, and you are not going to like what I have to say. Do not do this. This is wrong. This is bad math. This is crazy math. Please do not do it. Okay? Now, then we have when you're dividing, it's the same process. You can distribute the n to both terms. Okay? Remember that exponents and radicals are basically the same, right? Whatever I'm taking the root of will be the denominator in my exponent. Okay? So, Annalena, if anyone's still writing, please pause now. If we were to say the square root of a times b, what would that look like if I wanted to, quote unquote, distribute? All right? So, saying the square root of a times b is the same thing as saying a times b raised to the 1/2, right? Well, I know when I have an exponent and I have two things that are being multiplied, I can distribute the 1/2 to each of these. So a to the 1/2 times b to the 1/2, okay? And I know that 1/2 is the square root, so I can go back and I can put square root of a times the square root of b. These two things are the same, okay? So it would be okay if you had something like this to separate them like this, okay? Going over to the square root of a divided by b. It's the same process. I can take the square root and put it on the outside as an exponent, right? And then I would just distribute the a to the a and to the b. And I know that that is the same thing as saying square root of a over the square root of b. Okay? These are the same things. Okay? So, if you need to pause, Annalena, go ahead and do that so that way whoever's writing can finish. Okay, so what if we said the square root of x divided by the square root of y? Well, if I wanted to simplify this and make it more condensed, I could do that. So I could say that the square root of x is the same thing as x to the 1/2. And the square root of y is the same thing as y to the 1/2. And I know that when I have exponents that are the same, I can take them out, and I can say x divided by y to the 1/2, which is the same thing as square root of x divided by y. Okay? Same thing over here for number 2. I have square root of x times the square root of y. Even though you don't see the times here, it is there. It's imaginary, okay? And that's okay if you don't put it there. So, x to the 1/2 times y to the 1/2 is the same thing as saying xy to the 1/2. And the 1/2 we know is the square root. So these are the same things, right? I just went backwards. All right, Annalena, if anyone's still writing, please pause now. Okay, so I have the square root of 3, and what's that operation again? That's in between there, I don't see it. Multiplication, yes. So square root of 3 times the square root of 2, right? But I don't like that. I think I can simplify that. And we know that we can, right? We just did it on the last slide, except it was with an x and a y. So I can rewrite this as 3 to the 1/2 times 2 to the 1/2. And then I can take those 1/2s and I can put them on the outside of 2 parentheses. So I have 3 times 2 to the 1/2, which gives us 6 to the 1/2. And that 1/2 is the same thing as square root. So I can say the square root of 6. Okay, so this and this are the same things. Now, I'm looking at B, and it looks a little weird. Doesn't quite look like A, but it does. Does and it doesn't, right? So, in between the 2 and the square root of 5, what is right here? Anyone? Yeah, it's multiplication. Good job. So, hopefully somebody said it, because that would be awkward. No, so what I could say is that, well, let's take a second from that. So if I said AB times CD, isn't that the same thing as saying ADCB? It doesn't matter which order I put them in because they're all being multiplied, right? Well, that's the same thing here. Doesn't matter which order I put these numbers in because they're all being multiplied by each other. So I could say 2 times 3 times the square root of 5 times the square root of 2, right? This and this are the same, exactly the same. It doesn't matter which order I put them in, okay? So, now I can simplify. I know that 2 times 3 is 6, and then I have the square root of 5, which is the same thing as 5 to the 1/2, and I have the square root of 2, which is 2 to the 1/2, and then I can combine those, right? So I have 6 times 5 times 2 to the 1/2. And then I can simplify that by saying 6, and then 5 times 2 is 10, and I know that that 1/2 is actually the square root. So then I can say 6 square root of 10. You could say 6 times the square root of 10, but you don't need to. You can just say 6 square root of 10. They are the exact same things, but in math, we want to be as efficient as possible, and I don't have time to say the word times. So 6 times the square root of 10 is a mouthful. I'd rather just say 6 square root of 10. So much easier, don't you think? I think so. Now, Annalena, if anyone is still writing, please pause now. Okay, simplify. I have the square root of 32 divided by the square root of 2. Yep. So, I want to make this just one full number. Okay? I don't like the fact that there's a square root of 32 and a square root of 2. I just want it all 1. So I'm going to simplify it. Okay? I know that the square root of 32 is the same thing as 32 to the 1/2. I know that the square root of 2 is 2 to the 1/2. Okay? So what I can do is I can combine those into one square root. So I have 32 over 2 to the 1/2. And I know that the 1/2 is just the square root, right? Well, 32 divided by 2 is 16. And I know that the square root of 16 is 4. So that is simplified. That is the square root of 32 divided by the square root of 2, which is 4, right? I just showed you how it's 4. So when you're simplifying, you can get a full number, but that doesn't mean that you always have to get a full number. I don't know why I say full number. I mean to say whole number. It's weird. Anyway, so let's look at D. Okay? Now, I see square root of 12 divided by 2 square root of 3. And it kind of looks like C. I see 2 square roots, but there's this 2 down here. I don't know what to do with it. So instead, I'm just going to separate it. I'm going to distance myself from the 2. And I can do that by not doing crazy math, but logical math, right? So if I take the 2 away, it's actually 1/2, right? It's not a full whole 2, it's just a half, right? So there's like a 1 here. I don't see it, but I can separate it. So 1 times the square root of 12 over square root of 3. These two are the same problems, right? I haven't done anything crazy. It's like factoring, right? I factored out a 1/2, okay? So, looking at this now, I can do what I was doing to C, and I can combine the 12 and the 3. It's just that this 1/2 has to tag along, okay? So 1/2 times, and then 12 to the 1/2 over 3 to the 1/2, and then I can put those in one whole division problem to the 1/2. And then I know that 12 divided by 3 is just 4, and I know that the 1/2 is actually the square root, right? So then I have 1/2 times 2, which just gives me 1. Okay, so square root of 12 divided by the 2 square root of 3 is just 1. Okay, take a deep breath. I know we went over a lot in the past 13 minutes, but that's good. We're making progress, right? We're still learning, even though she's not here to teach us. But I am here to teach you, right? Crazy. All right, so Annalena, pause now if anyone still needs to write. Okay, so here's the thing. There's this weird notation, right? 2 square root of 5. This monster, I don't know what it is. To me, it's a monster because I don't understand where it came from, right? Like, I don't know its history. I'm going to show you the history now, okay? In order to know the history of this little monster, we have to know that the square root of AB is the same thing as the square root of A times the square root of B, okay? These are both the same things. We want to figure out this monster, and we want to understand its parents, okay? So where did this come from? What does it mean to be 2 square root of 5, okay? So, in your, let's look at the example, square root of 75, okay? We want to make it look like this, okay? And we want either A or B, doesn't matter. We want one of the terms A, B to be a perfect square. What is a perfect square, Miss Diaz? I don't know. Well, I can tell you. A perfect square perfect square, because I don't have time to write out the word square. A perfect square is the result from multiplying any number by itself, right? So if I had 3 times 3, I'm multiplying it by itself, right? So the result, 9, yes, that is a perfect square. 9 is a perfect square, okay? All right, so I want A or B to be one of these perfect squares, okay? So let's think, what is a perfect square that is a factor of 75? Anyone? 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 25, right? 25 is a factor of 75. And I know that 25 is a perfect square because 5 times 5 is 25, right? So I can rewrite this as 25 times, and then I divide 75 by 25 and I get 3. Okay? Now, in your book, it's going to say rewrite such and such in the form k square root of 3, and it wants you to find k. But I say ignore that completely and look for perfect squares, right? Because when you're given square root of 75, the problems aren't going to say, hey, by the way, you should divide this by 3 in order to find the perfect square, right? You need to figure out what the perfect square is that is a factor of this number that's inside the square root, okay? So don't really pay attention to this part. Just look for perfect squares that are factors of the number here, okay? So now that I have the A and the B that combine to equal the 75, now I can separate them. Okay, so I have square root of 25 times the square root of 3. Okay, well, what is the square root of 25? We already said it, right? It's 5. So now I have 5 times square root of 3. But what did we say about that? I don't have time to say times, right? So instead, it's just 5 square root of 3. Oh my goodness, now we get it, right? So if I wanted to find the beast that is 2 square root of 5, all I'd have to do is square the 2 and put it back into the thing, right? So 5, and then you get 4, which is 5. So square root of 20 is the parent of 2 square root of 5, right? The monster 2 square root of 5 is square root of 20, right? These are the same things. Sorry, it's a little messy. We'll do another one. How about that? Annalena, go ahead and pause now if anyone needs to continue writing. Muchas gracias. Alright, guys. So, we have the square root of 44, right? What is the perfect square that goes into 44? Anyone? I can't hear you. Speak up. I'm all the way at home. Can you? Okay, yeah, 4. Good. Okay, yeah, 4. All right, fine. 4. Okay, so 4 is the perfect square, right? Well, what am I left with when I take out a 4 from 44? You're left with 11. Okay, so now I can separate these. I get square root of 4 times the square root of 11. Square root of 4 is 2 times square root of 11. But we don't like the time, so we're just going to take it away and we're going to have square root of 11 because these are the same things. We want to be as efficient as possible. Right? Right. Okay, good job, guys. Good job. So proud of you. So proud. Now, look at the second example. Square root of 12 divided by 16. I think that we should separate them, right? So we know that if we have the square root of a divided by b, this is the same thing as saying square root of a divided by square root of b, right? So let's do that. Let's separate them. Square root of 12 divided by square root of 16. Well, what's the square root of 16? It's 4, right? So 4 goes on the bottom. Now, square root of 12. What is a perfect square that is a factor of 12? Bridget, got anything for me? Yeah, possibly 4. Yep. So square root of 4 times 3 gives me 12, right? I haven't changed my problem in any way. I'm just manipulating it so that way it looks like I want it to look, right? So I can separate square root of 4 and the square root of 3, and I bring down the denominator 4 because it hasn't gone anywhere, right? It hasn't disappeared. It's still with us, okay? And now I just simplify. So I have the square root of 4, which we know is 2 times square root of 3 divided by 4, right? Well, what is 2 divided by 4? It's 1/2, right? You could cancel out the 2 and the 4, and you would say a 2 it goes here and a 1 goes here. But 1 times square root of 3 is just square root of 3, and you have a 2 down here. This is simplified, okay? So just to recap what we did, right? So we had the square root of 12, or the square root of 12 divided by 16, and we separated those two things, right? Because I saw that 16 was a perfect square, right? So I want to go ahead and deal with that, and then I can deal with that 12 on its own, okay? So if I take the square root of 16, I get 4. We know that. Now we went it back up to the square root of 12, and we said, what is the perfect square that I can factor out from 12? Well, that's 4. And we said, what's the other factor that of 12 when I take out the 4? It's 3. And then we separated the square root of 4 and the square root of 3, and then we simplified, right? So square root of 4 is 2, and square root of 3 is just square root of 3. And then you bring down that 4 as well. And so then we had 2 square root of 3 divided by 4, and we said that 2 and that 4 can be simplified. So we took out a 2 on both the denominator and the numerator, and we got square root of 3 divided by 2. Okay? Now, this is the end of the video. Okay? You guys, this is the last period of the day, and you're so lucky because I'm such an amazing teacher that you get to leave early. But I will be here tomorrow, so make sure that you are in class on time at 9 o'clock in the morning. Do you understand? Yes, Miss Diaz. Yes, Miss Diaz. Okay, so be here at 9 o'clock in the morning. Don't play with me. You better be here. Okay? All right. Have a good night, guys, and thank you so much for staying through the entire thing and doing it. And Annalena, thank you for being the pause and bringing your computer. Hopefully, you remembered. Okay. Bye-bye, guys.